Off to our second video in 2.2. Well, there's going to be a lot of them. And again, this is what's going to set you up for success in the course. We got to get this stuff down. If you're going to slack anywhere, don't slack through this. But if you're already watching the video, you're not slacking. You're doing a great job. You're doing everything you need to do right now. Let's go. So here's kind of our game. We have a unit circle, right? We got our unit circle, which is x squared plus y squared equals 1. There it is, from before, and we talked about that. We defined these things. Some old dead dudes came up with some stuff, and they're like, all right, cool, sine, cosine, tangent. Probably some old dead ladies didn't get any credit, too. You know, history and all that stuff. Okay, so let's start defining things. Do you mind if I start superimposing? I'm going to start to superimpose, because from 2.1, we started to learn about angles and radians and degrees and how we go back and forth from them and where we start. So we always start. So let's go here and say that this is 0 degrees, right there on the positive x-axis. Actually, let me change my color. Let's use a different one. So we can see that even though we have an xy graph, we start at 0 degrees. This is where we start, on the positive x-axis. And the positive direction is this way. And now we'll get into some stuff that most of us have a pretty good idea. You know what a 90-degree angle is, right? So if we start here, this is where we're starting. And we were to come up to here, wouldn't this be a 90-degree angle? Of course it would. Of course it would. We get a 90-degree angle. Oops. Yeah, the degree symbol on there. If we were to take this around and go all the way over to here, we'd be at a 180, wouldn't we? So that's 180 degrees. Go down to the bottom, we're just adding 90 degrees. That'd be 270. And then if we wrap back around, we get to 360. That's the same thing. So a way to get this description down, like, why is 0 and 360 the same thing? Well, it's where you end. It's what we call coterminal. It terminates at the same spot. So if you're to be, stand up, and now make note of the direction you're in. Now spin around in a circle and go back to where you started. You did a 360. But you're still pointing the same direction. That idea is what we call coterminal. More on that in the future. But for now, we want to start defining something which we call a quadrantal angle. Sounds fancy, huh? A quadrantal angle. And I think it's a little easier for us to describe it rather than define it. Like, what is a quadrantal angle? Well, let's talk about, in the word, is quadrants. Don't we have quadrant 1, quadrant 2, quadrant 3, and quadrant 4? Remember that, don't you? If not, oh well, that's how it works. Quadrant 1, 2, 3, and 4. We have 4 different quadrants. That XY graph breaks things into 4 pieces. So if we were to have like the description from before where we had an angle coming through here, some sort of angle, that would not be quadrantal because it's in a quadrant. Quadrantal angles are not in any quadrant. They're actually on the XY graph. Those are quadrantal, things that are not in any quadrant, right? The positive y-axis, the one that's going up, that's splitting quadrant 1 and quadrant 2. It's not in quadrant 1 and it's not in quadrant 2, so we call it a quadrantal angle. And what we want to do is we just want to define what sine of 0 degrees, what sine of 90, what sine of 180, what sine of 270, what sine of 360. These are all quadrantal angles. So let's start with this. But here's the key. Sine is just the y value on the unit circle. Just on the unit circle. Soon you'll see the differences. But for now, we're just talking about the unit circle with a radius of 1. And we're like, okay, well, let's go find sine of 0 degrees. What is that? Oh, by the way, this is equal to sine of 0 radians. You can tell the difference because one has a degree symbol and one doesn't. So whenever you're doing your work, you want to make sure to use a degree symbol when you're in degrees, or else your teacher will think you're speaking of radians. So we look and we're like, okay, let's zoom in. At 0 degrees, what's our x value? It's 1. What's our y value? It's 0. What does sine go with? Oh, sine goes with y. Thus, it's just whatever the y value. What's the y value? It's 0. Sine of 0 is equal to 0. And don't worry, you'll forget most of the stuff. It's all good. It's all good. Because we'll start dealing with things that are non-quadrantial, and I think that'll make a lot more sense. So let's just keep going around in a circle with all our quadrantial angles, right? The 0, the 90, the 180, the 270, the 360s. Dot, dot, dot. And they go on forever. You make as many angles as you freaking want to. So now we're going to go to our y value for 90 degrees. And that's 1. So sine of 90, which is equal to, I'm going to skip this, is sine of pi over 2. That's in radians. That's equal to 1. Now let's keep going around in the circle. Let's look at 180. And our y value is 0 there. So that means that sine of 180 degrees, which is the exact same thing as sine of pi. Pi radians is the same thing as 180 degrees. So that's equal to 0. Are you seeing it yet? Can you figure out, can you already answer what sine of 270 going to equal? Can you see it? I'm even going to jump the radians. Can you see it? Can you see the y value? It's -1. It's just -1. Oh, so it looks like on those quadrantial angles, sine just goes, the answers are just 0 or 1 or 0 or -1 or, And just to jump past this, this is sine of 3 pi over 2. We'll get better with radians as we go along. We will. And then we have sine of 360, which is spin around in a circle and end up right back at the same exact frickin' spot we had for 0. So since sine of 0 is equal to 0, sine of 360 must also equal 0 because look, what's the y value? And just by the way, 360 is 2 pi. That's what it takes to get around in a circle. So there's some quadrantial angles. Now we can also do this with cosine. And cosine just goes with x. So our x value at 0 degrees is 1. Cosine of 90 degrees, which is equal to cosine of pi over 2. What's that equal to? 0. Cosine of 180 degrees, which is the same thing as cosine of pi, is equal to, what's our x value? -1. Sorry. We're talking about cosine, aren't we? Cosine 270, cosine 3 pi over 2, same gosh darn thing. It's 0. And then cosine of 360, which is exactly the same thing as cosine of 0, and that's equal to 1. So there's our quadrantial angles, but I think we could have just seen this. Doesn't cosine go with x? It says so right here. Cosine of theta is x. Let me ask you, when you're on the positive y-axis, what's x equal? You know, like 1, 2, 3, 4, this goes -1, -2. What's x equal when you're on the y-axis? X is equal to frickin' 0. So anytime you're on the y-axis, cosine will equal 0. Similarly, since sine goes with y, the x-axis is where y equals 0. Hence why, when we're at 0 or 180 degrees, sine is equal to 0. There's our games. Now, one last piece, and I'm going to let you go. We'll move on to, well, more about it. There's only 2 trig functions, essentially. Yeah, there's 4 other ones. But there's only 2. Really. Because tangent is just a combination of sine and cosine. Look. Tangent is just sine divided by cosine. Y divided by x. So tangent of 0 degrees, which is the same thing as tangent of 0 radians. Remember that we're plugging in the angle inside. Well, we're going to get 0 divided by 1. It's 0. Tangent of 90, which is the same thing as tangent of pi over 2 radians. Well, that will now be 1 over 0. Oh, hell no. That's undefined. You can never divide by 0. Very, very bad. Your teacher's a jerk about that, so make sure you never divide by 0 and say it equals 0. So 180, that will be 0 divided by -1. And that's equal to 0. Tangent 270 is the same thing as tangent of 3 pi over 2, as we learned in the last one. And that's going to be -1 over 0. Oh, no, don't even write that. That's undefined. You can never divide by 0. And then tangent of 360 is equal to tangent of 2 pi, which is also the same thing as tangent of 0. So we just get 0. So there's our beginning problem. Sorry this one's so long. I usually try and keep my trig videos pretty short, but this is a big piece, and you're going to see it over and over and over. So if you don't catch it right away, that's okay. But you got to keep looking at this, because you're not going to be able to use a calculator to solve these for your first test, for your midterm. We got to make sure that we have these things dialed. You're going to have to come up with these off the top of our head, and I don't want you necessarily memorizing. I want you to learn some tricks. Okay, I'm babbling. Let me shut up, and I'll see you in a video very soon. Bye.